Hey guys, today we'll be solving LeetCode number 1665, minimum initial energy. So the question is a hard question and it is also the daily problem of today. And I've already written out the example over here, as you can see, but I've done something different to the example itself. The way I've written it out is not in the same order as the one in the example given. So first, before I explain anything, what is the question, right? So the first thing that the question states is we're given a tasks array, right? And in each entry, essentially we're given a actual and a minimum, and we have to determine like the total amount of energy that we might need, the total minimum amount of energy we might need to satisfy every task's minimum condition. Essentially that's what they want. So we need total to match every task's minimum. We don't really care about the actual in this question, right? Our main emphasis is on minimum itself, because if you have the minimum, then you can do the actual and you will get some leftover and you can carry that on onto your next task. And so what have I done with this ordering I've given here? So I've placed emphasis on the minimum, and what I've done is I've sorted the array such that the highest minimum comes first, and it's essentially like a descending array of highest minimum, right? So first of all, this is a greedy and this is a sorting problem immediately, because you can see I mean, you need to pick up a habit of greedy, but if you look at the question itself, whenever you have to like determine a simulation, usually it's greedy. So greedy and sorting was something that popped into my mind. But there's actually two ways to I actually implemented two things, and in this question there's two ways to actually approach it, right? Not one of them is not correct and the other is correct. I'll show you the two approaches that I used. So the first one I went with was sorting it like this, right? And the trick carries over to the next approach, but the only reason this one doesn't work is because you don't get the optimal approach, which is the greedy version. So we consider our total, right? I'll write down a total 0, and we start with a leftover of 0, right? You haven't done any tasks, so you don't have any leftovers, and then we will traverse through this array in this order. We will just traverse through it. So you will see 10 and 12. Okay, we need 12 as our cost, right? So if we consider our total right now, to complete the first task we will need 12, right? So could we say that we would need to start off with 12 if we wanted to do this? Yes, we could. So we would say, okay, I would need to borrow 12 essentially. So I will take the 12, and once I do 12 minus 10, I will be left with 2, right? So I took 12, I removed the 12, now I'm left with 2. Sorry, that should have been an L. So T equals to 2, L equals to 0. I took the 12, right? I matched it, and then I took out the 12 that I had, and then I came to 2. Okay, then let's do 10 and 11. Now we have left over as 2 from our previous task, right? And what's the difference between 11 minus 2? 9, right? So could we say that we need 9? Yeah, we could say that we need 9 more. We need to borrow 9 more now. So we will go with 9. So we will do complete this task 11 minus 10, because we refilled it to 11 only. Take out the 1 and we will be left over with 1. Now what's the difference between 1 and 9 if we consider this? 8, right? So we need to borrow 8 again. So we will do plus 8, and then we will do 9 minus 8. We will be left with 1. Then we will borrow 1 minus 4, which is 3. So we will borrow 3. We will do 4 minus 2. We will be left with 2. then we will have to borrow 1 because we need to reach 3. We have 2 left over, so we will do that, and we will be left over with 2, but all our tasks are done. So at the end we will consider this total now. So 12 plus 9 plus 8 plus 3 plus 1. So 8 plus 12, 24 plus 9 comes to 33, and the answer is actually 32. So we tried this approach, right? So what we tried was minimum first. We tried this approach. Actually, for the other 2 examples, if you do the same thing that I've done, it gets the correct answer, but the approach itself is a bit flawed. So this is something that I thought of first, right? Now the way to actually solve this question, I'll explain to you I'll explain what the actual approach is. But so the thing with greedy is, right, you have to just try and error some of these approaches in your head, because you need to make these locally optimal changes to get the global maximum change. So the next one, right, and since I already mentioned on the fact that we only emphasize on minimum, actual pretty much gets thrown out of the window in considering actual first, right? There's no point in considering actual first because minimum first should have been more viable. So what's left now? Well, the only thing left is a division or a subtraction or a multiplication. What makes the most sense in this question? We don't want the ratios, right? We just want to see the differences, right? And we've done that repeatedly already with the t equals to 0, l equals to 0 approach, where we just want to get these differences, right? So we will take the differences approach now. So we'll do 10, 12. So we will do 2, 1, 1, 2, 2. Then let's sort this in descending. So we want highest gaps first. So let's consider this array. We will now make it 10, 12, 2, 4, 1, 3, 10, 11, and 8, 9. Alright, so it goes 2. I'll write this here, 2, 2, 1, 1, 1. That's our gaps, okay? Now let's consider this. So we started with the same exact thing that I did before. T equals to 0, right? Leftover starts with 0 as well. We will take this task immediately. So we will do t equals to 12 because we need to hit this minimum. And we will see that we will be left with 2. 12 minus 10, 2, right? We'll take the next task. It's 2, 4. We need to hit 4, right? And 4 minus 2, that's 2. So we will take 2. L is equals to 2 after that, if we do 4 minus 2 after that. Now we need to hit 3. So 3 minus 2, that's 1. We will take that one over here. So we will end up hitting 2 on our left, 3 minus 1. Now we will consider 2 and 11. So 11 minus 2, how much is that? 9. So let's add 9 over here. Then close that. So 11 minus 10, we will be left with 1. And remember, when I do these like subtractions to try and fill up our few, after we're done with the thing, we end up hitting 0, right? And then we take whatever is left. So remember, we do a refillment every time essentially. Then we need 9, so we will do plus 8, and we will be left with 1. So let's consider the sum of this now. So we will do 10 plus 10 plus 12, and guess what? It comes to 32, and that is the answer. And if you do this for the other 3 examples as well, that's how it comes to be. So this is really just some trial and error. Now as for the code, there's 2 ways to go about this. So you can do lambda. So you can sort it descending, and you can give your key to be x1 minus x0. I'll show another way actually. So I did it's a bit more space heavy, but this is the first thing that I came up with. Pretty much you could say the naive version. So value and tasks. What did we do? So we took the actual, we took the need, and the first thing that we did, well, get our differences. Okay, so we will take need minus actual, because the need is always going to be greater according to them, and then actual and need, and we will store this as a list inside of the list. Then we will take our gaps and we will sort it, right? And since we've kept the difference as the first thing, it will sort based on that, and we will do gaps reverse is equals to true. Alright, now like I said, we will have a minimum. You can have it be total, whatever you want. Left, we will have those be 0. Now for value in gaps, so we'll iterate through that given list. We have our gap. We will not really consider our gap anymore. We just had to sort it based on the gap. Now we just need our actual and need values. That's what we care about. Now let's get to the question itself. So when did we refuel? When did we take up minimum energy, right? When did we add to our total, right? When did we add to our total? When our left was less than the minimum required for them, right? We didn't have enough fuel to meet their prerequisite. So when did we do that? So we did that when, if the leftover that we have is less than the amount we need. Okay, if it is less than the amount we need, then we need to refill first of all. So we need to refill the amount need minus left, right? You remember how I did it with 11 and 2, so we have to take 9, stuff like that. And then our left becomes our need. Okay, so we refilled it, now it's become our need, but after that we still have to perform the task, right? So then after that we do a minus equals to the actual, because we have to take out the well, we have to finish the task, right? Obviously. And if we are actually above it, right, if you're actually greater than or equal to, actually I'll write this out a bit more clearly. Else if left is greater than or equal to than what we need, well then just expand your left, that's completely fine, right? So expand your left, but don't expand it with the need, expand it with the actual. You can do a minus equal actual or whatever you want, right? And then at the end just return your minimum. That's pretty much it for this question actually. So try approaches. When you have a greedy solution, this is the code. When you have a greedy solution, greedy problem, sorry, try approaches, right? See which one gets you the answer, or what you think might be the best, right? Obviously go for your best possible thoughts first, and then you go for your worst thought first.